Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have brought a series for ISI and CMI preparation. Also, my today's topic is important ideas problems on functions, which will be equally important for JEE Advanced. So please go through this session, not only keeping ISI and CMI in mind, but also for JEE Advanced. So my first problem here is based on inverse of a function. We are asked to find the solutions of fx is equal to f inverse x, where fx is given as a quadratic. So what we normally do, we use the fact that y equal to fx and y equal to f inverse x, their graphs are symmetrical about the line y is equal to x, isn't it? So this is the line is y is equal to x, and the graph of y is equal to fx and y is equal to fx, f inverse x will be symmetrical about this. So whenever they are equal, they will be equal to x also. Okay, so first we will be solving for that, but let me tell you in the beginning itself that this is not complete thing. I will tell you why. So if you have to solve for fx is equal to x, you will get x square minus 5x if I bring that x this side plus 5 equal to 0, and this will give me x is equal to 5 plus or minus, I think 25 minus 20, so 5 here upon 2. So if I go with that domain, my value of x, and here it should have been open bracket, here also it should have been open bracket. So my x will be 5 plus, not plus, it will be minus actually, 5 minus root 5 upon 2. So that will be the solution of this fx is equal to x. But is it really the only solution for this? To understand that, let us make one diagram of fx and f inverse x, keeping in our mind that they are symmetrical about the line y is equal to x. So this is the line y equal to x. Okay, so here as you can see, this is a quadratic whose minimum value will occur at 2, which is also there in the domain. So let me take this as 2, this as 1, this as 2. So 2 comma 1 is the point of minimum. Okay, and the value at 0 will be 5. So if I draw the graph, it will be something like this. Okay, 0 comma 5 here. Now if I draw the graph of f inverse, so if there is a point 2 comma 1 here, 1 comma 2 will be lying on the inverse, corresponding point of fx will be corresponding point of f inverse x will be 1 comma 2. But please listen carefully, this 2 comma 1, not only 2 comma 1 but 1 comma 2 is also lying on this graph. You can check, if you put x is equal to 1, you are getting 2. That means a point that's a reflection of 2 comma 1 in the line y equal to x is also lying in the graph of fx. But that means if corresponding to 2 comma 1, 1 comma 2 is lying of f inverse x, corresponding to 2 comma 1 comma 2 also, there should be 2 comma 1 lying on the f inverse x. What I am saying, let me repeat. 2 comma 1 lies on fx, lies on fx. So 1 comma 2 will lie on f inverse x. But as 1 comma 2 also lies on fx, that means this 2 comma 1 will lie on f inverse x, which means both points should lie on both the graphs. So if I consider that thing, and also this point of intersection which we have found as 5 minus root 5 by 2, it should also be lying on both of them. So my graph will be something like this. Please understand. This 1 comma 2 will be lying on both of them, 2 comma 1 will be lying both of them, and this point, which is the point of intersection of fx with y is equal to x, will also lie on both of them. Let me show you one fair diagram of this. You can see this red graph is the graph of y is equal to fx, whose minimum value is at 2, that is equal to 1. Okay, and also it is having 1 comma 2 lying on it. And then this graph of y is equal to f inverse x. This is also passing through these 2 points, and this is also, and both of them also passing through the line y equal to x, and that is this point. So you can see there are 3 points A, B and C, you can say, that are lying on both of them. So there will be 3 solutions. So there will be 3 solutions. X is equal to 1, 5 minus root 5 by 2 and 2. The question is whether we should always check whether other solutions are there. In my opinion, you should. And this normally can be done by making a rough diagram. But do not rely only upon fx is equal to x thing. Otherwise, you will tend to lose these solutions. Although in most of the question you can assume that these kind of solutions will not be there, but you should not take chance of leaving these solutions. Now, what is there a solution, is there a method that we can find these points mathematically also? At least for polynomial functions I can say yes. How? Please see what I was saying. There was important note here that if a comma b and b comma a both lies on fx, they lie on fx also, f inverse x also. That is what I have said. Okay, you can understand that corresponding to ab, b comma a will lie on f inverse x, and corresponding to b comma a comma b will lie on f inverse x. Now if that is the scenario, what will happen? This point will satisfy the graph of fx, so we will get b equal to a square minus 4a plus 5, and also a equal to b square minus 4b plus 5. Now we can take the difference. B minus a is equal to a square minus b square minus 4a minus b. Okay, now as a is not equal to b, because we are looking for those solutions only, so I can cancel both sides by a minus b, and we will get minus 1 equal to a plus b minus 4, and this gives us a plus b is equal to 3. A plus b equal to 3. Now this equation 1 or 2 if I use to get a or b, I think we will be able to get the values. B equal to 3 minus a. B equal to 3 minus a. I can put in this equation number 1, 3 minus a, and this will be a square minus 4a plus 5. So you get a quadratic which is a square minus 3a plus 2 equal to 0, which gives us two values of a, that is 1 and 2. So I think this way also it can be identified whether such point will be there or not. Okay, so this completes the solution of this question, but I will tell you, I will use similar idea in one more question, but this question is not given the way it was given in the previous question. Here you can see we are given 9-degree polynomial equation. So is it possible really to solve a 9-degree solution? I think it's not that easy. So we have to think of something else. If you look at closely at these expressions, you can see the first three terms are such they can be used. They can be used to make a perfect cube. 3 by 8 x cube plus 3 by 8 whole cube. You can see the whole cube of this will be x power 9. Then 3 into 3 9 upon 8 x power 6, and then 3 into 9 27 upon 64 x cube. But there will be a constant term also, that will be 27 upon 512. So that is the expansion of this whole cube. So if I look at this, I think we are not having 27 upon 512. So that otherwise every term is there, so I will subtract it. Minus x plus 219 upon 512 is equal to 0. So you can see we will be getting this as x cube plus 3 by 8 whole cube, and if I bring everything on the right hand side, then it will be x minus 192 upon 512. This becomes, I think, 3 by 8 only. This 192 is 64 into 3, and 512 is 64 into 8. So we can write this as x cube plus 3 by 8 is equal to x minus 3 by 8 whole power 1 by 3. So if someone takes fx is equal to x cube plus 3 by 8, it is very easy to say that this will be equal to f inverse. So f inverse x will be equal to x minus 3 by 8 whole power 1 by 3. Okay, you just have to equate this equal to y and then interchange x and y. So this question is like solving, fx is equal to f inverse x only. So as I told you in our previous question, we will first solve it for fx is equal to x, which will give us x cube plus 3 by 8 is equal to x, which becomes 1 quadratic, x cube, which becomes 1 cubic, x cube minus x plus 3 by 8. And it is easy to see that x is equal to half is satisfying it. So x minus half will be one factor. Another factor would be for x cube I need x square here minus x square by 2, but there is no x square term here. So I think I need to multiply, I need to add x plus 2 here, and then constant term is minus plus 3 by 8. So I need to have minus 3 by 4. Also you can check that coefficient of x is also matching, yes. So these are the factors which we are getting. So from this we will be getting x is equal to 1 by 2 as one solution, and other solution will be x is equal to minus b plus or minus root over 1 upon b 1 upon 4 minus plus 1 it will become 3 upon 2. So you can see we are getting minus half. I can bring this 2 in the denominator, so it will become I think 13 here upon 2. So we are getting this A as answer and C also as answer, B is not the answer. So far we have got two answers, but what if we have a solution of kind of A comma B and B comma A? For that I will suggest that you just make simple diagram. As we have solved in our previous slide, fx what was x cube plus 3 by 8. Okay, and we got f inverse x is equal to x minus 3 by 8 whole power 1 by 3. So if I draw the diagram, if I draw the graph, so this graph of fx at 0 value will be 3 by 8, and it will be a point of inflection also. So the graph will be something like this. Okay, now y is equal to x line is going to intersect this graph at 3 points, which we have already found. I think minus 1 by 2 was 1 point, and these A and C options are also 2 options. I think minus 1 minus root 13 by 4 will be here. It can be checked actually, and minus 1 plus root 13, and one more we got as that was 1 by 2. So these will be here. Okay, now if I draw the graph of f inverse, which has to be mirror image in the line y is equal to x. So the graph of f inverse x, if I make keeping that into our mind, will be like this. Okay, like this. So you can see that here it looks like there will be only 3 solutions for fx is equal to f inverse x, because there is no chance that they can come back and they can meet at any other point than these 3. But if you want to do it by, let us say, that algebraic method that I told you, so what you can do, once again you can think of that a comma b and b comma a lying on both of them. So this will be lying on fx, so you can write b equal to a cube plus 3 by 8 and a equal to b cube plus 3 by 8, and if you take difference, b minus a will be equal to a cube minus b cube. If I divide a minus b both sides, it will be minus 1. On the right hand side, it will be a square plus ab plus b square. But dear all, you must be knowing this thing that is always positive. Why it is always positive? You can think of 2 things. One is that a plus b by 2 whole square plus 3b square by 4. This is how you can write this thing. So it is actually sum of 2 perfect squares, so it cannot be equal to minus 1. Also, this is, if you remember, a plus b omega into a plus b omega, b omega square into b. That's this is having 2 factors, a plus b omega, a plus omega square b, as omega and omega square are conjugate of each other, so it becomes the mod of square of mod of a plus b omega. So it cannot be minus 1. So you can see this kind of points cannot lie on this graph. Okay, so this is how you can do this. I will take one more example on this. Please see. This example is actually based on y equal to minus x plus sine x. Okay, this is invertible graph. You can check its differentiation will be minus 1 plus cos x, that is negative. Okay, negative or 0 at most at one point. but it is strictly decreasing function. And you can see its graph will be like this. If I draw y is equal to minus x, and this will be going like this. Now, if that is fx and I ask you to find the solution of fx is equal to f inverse x. So what you can notice here once again, that at value pi, at x is equal to pi, if you put, we are getting minus pi. And if you put minus pi, then you are getting pi, you can check. That means these will be lying on f inverse x also. In fact, if you would have solved it only with y is equal to x, you would have got only 0 as the solution. So here by graph itself it is seen that all x is equal to n pi are going to be the solutions for fx is equal to f inverse x. You can check. If you put n pi, you will get minus n pi. If you put x is equal to minus n pi, the value of this function will be n pi. So that means n pi comma minus n pi and minus n pi comma n pi both are lying on the graph of fx. So it will be lying on f inverse x also. So always take care of this thing. Okay. In fact, you might have already understood this thing, that if a comma b and b comma a lying on both of them, and slope of line joining both of them, these 2 points is always -1. So you have to think of one of such line where slope of line joining these 2 points will be -1. If such thing can happen, then only you will be able to get such solution. Otherwise there will be no such solution. Like in our previous example also, you can see this graph was strictly increasing. There is no chance that you may have 2 points lying on this graph of y is equal to fx or f inverse x where slope can be -1. Okay, so I hope you have understood what I'm trying to tell you. This is one very, very important thing to remember while solving such questions. Now coming to this question number 3, one very interesting question. Please see, we are given for a natural number n, denote by map n the set of all functions f such that 1 comma 2 and so on n to 1 comma 2 and so on n. For f comma g belongs to map n, fog denotes the function in map n that sends x to f of gx. It is just a composite of function, nothing else. Now we are having two parts. A part says let f belongs to map n if for all x belongs to 1 comma and so on n fx is not equal to x, then we have to prove that f of f cannot be equal to f. Now to prove this, I think we can take the assumption that this is true first, that f of f is f, and then we will find some contradiction, then we are done. Okay, so if we are assuming that, that means we are saying that f of fx is equal to fx. So you can see that fx, if I take as t or u or v, whatever, I think we are getting f of t is equal to t, isn't it? Where I have taken t as fx. So you can check, this is something that is given in the question, cannot be true, because we are given for all x belongs to this set, fx is not equal to x. So this is a contradiction. Hence, f of f cannot be equal to f. I think this A part was quite easy. But now let us come to B part, which is little challenging, you can say. It is saying count the number of functions f belongs to map n such that f of f is equal to f. Let us see how this is to be done. Now to do this question, this part B, let us take that B is some number that belongs to range of f. Okay, and this value b is the value of function is b on some number a. This f of a is b and b belongs to range of f. Then please see, if I use this f o f x is equal to x relation and put x is equal to a here, you will get f of b, because f of a is b, is equal to f of a here. I hope you are getting it. F of a is b, so f of b will be equal to f of a, and because f of a is b, so it will be equal to b. So what conclusion I have drawn from this, please listen carefully, that if you have some element B in the range of F, okay, then this F of B has to be equal to B. Suppose there were B1, B2 and so on B3, they belongs to range. In that case, as we have proved here, my F of B1 will be equal to B1, my F of B2 will be equal to B2, F of B3 will be equal to B3. Okay, now those elements which are beyond range, like other than these, suppose B1, B2, B3, there will be n minus 3 elements. So these elements will be connected to one of these B1 or B2 or B3, because range is having only 3 elements. Okay, they will not be connected to themselves because the range is only B1, B2, B3. So now here, depending upon how many elements in the range are, okay, we have to connect all the remaining elements in the domain to these elements. I'll take just one example. Suppose my range, let me take case 1. Suppose my case 1 is that range is just one element. Range is just one element. Okay, it can be 1, it can be 2, it can be n. Okay, so the value of function at that element will be itself, and let this is B only. This element be B. This element is B. In that case, what you can see, FB will be equal to B only. In fact, all the elements 1, 2, 3 and so on, and they will also be taking this value B only. I hope you are getting it. So in this case, how many possibilities are there? I think first of all, NC1, I will say that which one element will there be in the range. Okay, and then all the n minus 1 elements will be connected to this one only, this B only. So 1 power n minus 1, I will say. Now, if I take case 2, case 2 means range has 2 elements. Range has 2 elements. Let us say B1 and B2. In that case, f of B1 will be B1, f of B2 will be B2. Okay, f of B1 will be B1 and f of B2 will be B2. And in this case, what will be the number of ways of doing this thing? I think first of all NC2, because out of n elements, which 2 will be there in the range, so I will take that as NC2. And then other than these B1 and B2, there are n minus 2 elements. They will be mapped to either B1 or B2. So each of these elements from 1 to n except B1 and B2, they will be having 2 options each. So 2 raised to the power n minus 2, I can say. In fact, here we can take case 3. I can write this as case 3. So what will be the number of cases here? NC3 into, it will be 3 power n minus 3, because all remaining n minus 3 elements will be having 3 options each. So that will be the answer of this case 3. But now question is, how many cases do we have to make? I think we can go up to n. In that case, my answer here can be written as a sigma, and that will be summation NCR, and I will write here as I think R raised to the power n minus R, where R will start from 1 and it will go till n. In fact, when R will become equal to n, this function will be fx is equal to x, and there will be only one scenario. You can check from here also, when R will be equal to n, we are getting only answer is 1. So that will be the answer of this question. We may leave it here also, and you may think of some way of simplifying it. Okay, so this is how this question is to be done. I think very interesting question. In fact, I have got one milder version of this question in the form of this question number 4, which says find let f is a function from 1 2 3 4 to 1 2 3 4, and f satisfies f of fx is equal to fx. Okay, so isn't that exactly same question? So what we will do, we will be taking first case where only one element in the range, so 1 raised to the power 3. Let me check it from here. Yes, so when R is 1, it will be 4C1 and 1 power 3, and the next one would be 4C2. Then the remaining 2 elements will be having 2 options each, and then 4C3, then only one element will be having 3 options. And then 4C4, I think there is no element remaining now, so I think you can write this as 4 power 0 or also. So here you can see the answer will be 4 plus 6 into 4, 24, plus 4 into 3, it is 12, and 1 here. So how much we are getting, let me check once again the calculation. 4 here, 6 into 4, 24, that's correct. 4C3 is 4, 4 into 3, 12, that is correct, and 1 here. So 36 plus 4, 40 plus 1, 41. So answer for this one will be C. So that is direct application of this question only. Okay. Now coming to one interesting question, this is from CMI previous years. It says the domain of a function f is the set of natural numbers. The function is defined as follows: fn equal to n plus jint of under root n. Prove that for every natural number m, the following sequence contains at least one perfect square, m, fm, f square m, and so on, where f power k is actually the composite of f with itself k times. So f square means f of fm, f cube means f of fm, and so on. So just to give you the feel of this question, let me take one value of m, let us say 8. Okay, then f of 8 will be actually 8 plus jint of root 8, which will be I think 2. So this will become 10. Now, if I take f of 8, it is actually equal to f of 10. So if we do it for 10, it will be 10 plus jint of root 10, I think it will be 3, so we get 13. Now if we take once again f of f8 3 times, I can write this as f of 13. So this will be 13 plus 3, and you can see it is coming out to be perfect square. So maybe we have done it 1, 2, 3, 4 times, but we have got it as perfect square. So that is what we are supposed to prove, that for any natural number it will always be a perfect square. Now to prove this, let us do it in general method. First what I'll do, I will take my n to be lying between k square to k plus 1 whole square, in which k square is included, k plus 1 whole square is not included, so that the jint of under root n will always be equal to k. You can check. In fact, I can draw this n on number line where I will start with k square, included k square, and I will write here k plus 1 whole square minus 1. Now this is also included. Here k plus 1 whole square was not included, but if I subtract by 1, it will be included. So these are the values which we can take for n. So suppose I take n to be equal to k square plus r, in which r I am taking from 0 going till 2k. This can be written as k square plus 2k also. Okay, so in this case, what will be my value of fn? It will be k square plus r plus k, because jint value will be k only. Okay, now there are chances that this fn is still between k square to k plus 1, but it can be beyond that also, but it will depend upon the value of r. Please see, if I take my r from 0 to I think k, including k, so I will be getting this as k square plus k plus r, let me write this way, and it is still between, this is still between k square and k plus 1 whole square. You can check, because even if I take the largest value, it will be k square plus 2k, it will be this number only. But if my r is greater than or equal to k plus 1 and it is less than or equal to 2k, I can write this as k plus 1 whole square plus r minus k minus 1. It can be checked, it will be r minus k minus 1. Now there is one very interesting thing, please listen carefully, that there are two categories. This is category 1, let me call this as A, and this is category 2, let me call this as B. Here if you notice, this value k is actually the midpoint of this k square and k square plus 2k, because when r will be equal to k, this point will be k square plus k. Okay, so my category A is when my this r is from k square till k square plus k, which is the midpoint of k square and k square plus 2k. Okay, and the category 2 is when it is beyond this. This is my second category when r is from k square, k plus 1 to 2k, so that my value of n is from k square plus k plus 1 up to k square plus 2k. Okay, but listen carefully, one interesting thing here, even this case of b, if you notice it here, this r minus k minus 1, this will be lying from, if I put r as k plus 1, it will be lying from 0 and it will be going till k minus 1. If you put r as 2k, it will be going from 0 to k minus 1. Okay, so what I said that fn, which I took as k square plus k plus r, my first case A, in which it was still between k square and k square plus 2k, or I could have taken this as k square, k plus 1 whole square plus r minus k minus 1, and this is my category B. So if you look at this category B once again, what you will see that this is again actually kind of category A only, because this new number, you can see it is lying between 0 to k minus 1. Yes or no? It is lying between 0 to k minus 1. You can think of that this new value of n, which was earlier k square plus r. Okay, now I will take fn to be, let us say, capital N, and in this category B I am talking about, this my n is actually k plus 1 whole square plus, and let me call this as r dash, and in this case r dash is between 0 to k minus 1. And if you draw it on that number line once again, where it starts with k plus 1 whole square and it goes till k plus 2 whole square minus 1, and its midpoint, if you mark like the way I did here, you can see this r dash will be, this k plus 1 whole square plus r dash will be lying on this first part of this, this interval. So in this case of B also, you can think of that after taking one time my f function, it will be coming in the first part of this interval. In fact, in both cases, if my r is between 0 to k, then also it is lying in the first part of this interval. And if r is lying in the second part for n is equal to k square plus r, when I take fn as capital N, then in terms of capital N, then also for this interval k plus 1 whole square to k plus 2 whole square minus 1, it is again lying in the first half only for this interval. So what we can say in all possible scenarios, whether r is lying in the first half or in the second half, we can manage to get it in the first half only. Okay, I hope that is clear. Now, so let us assume that r belongs to, or let me write this way, let me say that, so let us say that r is lying between k and 0 only, can be taken as a general case. And now to do it further, I will take f of fn for that case number A. I will take this for case number A, this which was this thing. Okay, so what we will get? We will be getting k square plus k plus n, k plus k square plus k square plus k square plus k plus r plus gint of under root of k square plus k plus r. And as you can see, this is still k only. So I think this will be k square plus 2k plus r, whom I can write as k plus 1 whole square plus r minus 1. So what you can notice here is that my first fn, my n, which was k plus r square types, which was actually k square plus r type, my f of n has become k plus 1 whole square plus r minus 1. Now if I do it 2 more times, I think here we will get k plus 2 whole square, and here I'll be getting r minus 2. So that means doing it 2r times, we can definitely get this to be 0. We can get this thing to be 0, and we will be getting this to be perfect square. Okay, so this is how we can do this question, for general value of, this n. Now coming to this question which says px is equal to x square minus x plus 1, and alpha is the 0 of p of p of p of p 4 times px. We have to find the value of mod p alpha minus 1 into p alpha into p of alpha into p of alpha 3 times. Now please see, if I say px is equal to 0, I think it is very easy to notice that roots will be, I can write in terms of cube roots of unity, omega, and minus omega square. Now, if you try to find, and you can write this, because alpha is the root of this 4 times p here, so I can say that p of p alpha will become equal to either omega or minus omega square or minus omega. So you can at least get rid of this thing. But if you will try to check what will be the value of p alpha, it becomes humongously difficult to solve this way. Then what is the method? Please listen carefully. Once again, one very, I should say a very smart trick will make this question easy. Please see how. This p of alpha minus 1 into p of alpha, if I take this as my initial calculation, I can write this as alpha square minus alpha, because 1 will be cancelled, and p of alpha I can write as alpha square minus alpha plus 1. Now if I add 1, let me write this way, alpha square minus alpha plus 1 minus 1 in that first bracket into alpha square minus alpha plus 1. So I think this can be written as alpha square minus alpha plus 1 whole square minus alpha square minus alpha plus 1. So can you see it that it has become actually p of p alpha minus 1. Actually this is p alpha, and p alpha minus 1 means alpha square minus alpha. So in place of alpha we have actually written p of alpha. So p of alpha minus 1 into p of alpha has become this thing. So can we say that, let me write whatever they have asked, let me call this as mod of, let us say capital X. So this mod of capital X, if I combine first 2 brackets, so it will become p of alpha minus 1 into p of p alpha 2 times, and then p of p alpha, here p is 3 times. So similar to what we did before, if we combine these two, I think this will become p of p alpha 3 times p and minus 1 bracket, and then 3 times p of alpha. Okay, so 3 times p alpha minus 1 into 3 times p alpha, I think this will become just 4 times p, 1, 2, 3, 4 times alpha minus 1. And because alpha is the root of this thing, so this will become 0, and hence we get this as minus 1, mod will be equal to 1. So this is how this question can be solved. Now coming to teaser question, but before that, all of you, if you're going to prepare for JEE Advanced this year or next year, please go through this Vedantu Eklavya. It is one big thing in online domain. It will help you a lot for JEE Advanced preparation. I am sharing with you the link of topper notice board here, where you will be getting all important informations of new batches coming up or new things going on these batches. Just click on this link or scan this QR code. In fact, these links or QR code are shared in the description box also. Here 2020 is, I think, already over, so coming to 2023, those who are going to write JEE Advanced in 2023, please join the Telegram channel using this link or this QR code. We will be updating all important information regarding our new Eklavya batches in that channel. Same for 2024 students. Dear all, we are creating solutions of all important previous year exams like JEE Advanced, KVPY, ISI, CMI in single question format, and we have uploaded them on this channel called V Impact channel. So please click on this or scan this QR code. You will be going to the channel and you will be able to access all those solutions. Okay. Now coming to this teaser question, it says let A is this 1, 2, 3, 4 up to 9 and F is A to A is a bijection 1, 1 and on to such that F n times is equal to Fx. There was one similar question in our class today also. But what they are saying additionally that none of FOF or FOF 3 times or FOF n minus 1 times, they should not be identical to F. Okay, you have to find the largest value of n for this 9. Options are given: prime number divisible by 3, number of positive divisors of it is equal to 4 or divisible by 4. Now, if you have done this question, do not forget to send it to eklavyaSupport@vedantu.com with subject line teaser solution maths. Here it should be maths. Okay, and if we like your solution, we will be reach out to you and we have interaction with you, and whatever batches we find suitable to you, we will make you part of it. So that is all for today. Thank you so much. Bye everyone.